Let's have a interesting look at the concept of limits through geometry, and here we are having a very nice problem, that is you have a polygon which is inside a circle, and a circle of radius r, and the problem is that the question is that how many sides should that particular polygon should be having, so that it can completely fill the area of a circle of radius r. Now, the point here is that I am trying to uh, uh, have a very interesting look at the concept of limits, and of course we can do this particular problem, but we are in this particular video we are looking at the final aspects of limits through this particular question, and let us have a re-look at the problem. Now, as far as a function is concerned, we know that the general representation is f of x is equal to y, and here the interesting point is that the x values, the input values, is the sides, in the sense that you have the x values, that is the sides, and so the sides of the polygon, and the y value is dealing with, that output is dealing with the area of the polygon. Now, the key point here is that what is the number of sides which should be there, so that the area of the polygon should be is equal to the area of the circle. Now, the interesting thing is that suppose it goes like a1, you'll be getting an area which is very much less than the area of the circle, which simply means that it is very much less than pi r squared. Let us go on to an. Now, a here represents rational numbers, and an is the point at which uh, the polygon, that is the sides of the polygon, are such that you are getting the area of the circle. I mean, the area of the polygon is equal to the area of the circle. Now, what is the interesting? There's a very important, interesting point here, and that point is that I mean, when you are reaching that particular point, that is this point, when you are reaching this point, the polygon won't exist. What does I mean? What is the meaning of saying that the polygon won't exist? Let me make the point once more clear. Now, as the sides of the polygon are increased, a particular point will be reached where the area of the polygon would be equal to the area of the polygon would be equal to the area of the circle which surrounds it. What does this mean? It simply means that we are not dealing with a polygon, because if the area of the polygon should be equal to the area of the circle, then it simply means that instead of a polygon, we are dealing with a circle. So that's the limit, which simply means that in this particular case, when the side is an, when we reach the side an, the area would be pi r squared, which simply means that you can't, in this particular case, you can't reach pi r squared, or an is not possible, because then you are not dealing with a polygon, you are dealing with a circle. So n is the limit as far as the input value is concerned, and pi r squared is the limit as far as the output value is concerned. So how do you represent it? How can you put it in a mathematical format, and That's a point which we are looking at. So limit as x tends to or approaches a n. So that is so the area of the polygon is equal to pi r squared, and pi r squared of course is the area of the circle. So as we reach very extremely near to a n, that's as the sides of the polygon is so a n, but it can't reach a n, because if it reach a n, then the area of the polygon would be equal to pi r squared, which is not allowed, because if the area of the polygon is equal to pi r squared, we are not dealing with a polygon, we are dealing with the circle itself. So that's an interesting point, and I hope the dear viewers have uh, enjoyed this particular video, and that your esteemed feedback is would be welcome. Thank you.